Today we are going to look at solving absolute value inequalities. So for example, we have the absolute value of x is less than 4. Again, when I look at these, even more with the inequalities, it's important to remember absolute value is distance. So if we're looking at our number line, and we've got our 0 here, we have a distance from 0. There's a distance of 4. And it could also go the other direction to negative 4. And our distance from 0 is less than 4. So we don't go this far, we don't go this far. So it's somewhere between negative 4 and 4. And so when I see an absolute value less than 4, I think, hey, it's less than, so it's going to be between 4 and negative 4. So I'm going to set this up by writing it as negative 4 is less than x, which is less than 4. And I'm done. This one is straightforward and simple. Now, what happens if I have the absolute value of x is greater than 4? Let's make it greater than or equal to 4. Absolute value of x is greater than or equal to 4. Well, going back to our diagram, what does that mean? It means the distance is more than 4. So either I'm way over here or I'm way over here. And so I am out here or out here. One of these two things to make the distance more than 4. And so I have two options. Either x is less than or equal to negative 4, or x is greater than or equal to 4. And we just have the or equal to is the same. Since it's or equal to here, the answer has or equal to. No or equal to, so no or equal to. So a greater than follows that pattern. And this is the rule that you're going to be looking for. When you have a less than, it means the distance is between. When you have a greater than, it means it is outside of two ranges, so it's either way small or way big. So let's look at some more complicated ones. For example, absolute value x minus 3 is less than 4. Again, how do we do it? Exactly the same as we did before. It's less than, so we think the distance is less than 4. So this value has to be between negative 4 and positive 4. So negative 4 is less than x minus 3, which is less than 4. And this really is showing between because we're saying this thing is bigger than negative 4 and smaller than 4. Now, how do we solve a compound like this? Simply add 3, not to both sides, but to all three sections. It's divided up by the two less than things. When we talk about adding to both sides, we're always looking for a comparison, an equal sign or a greater than sign or whatever. So when we add 3 in all parts, we end up with negative 1 less than x less than 7. And we're done. If we'd done that same thing with greater than, absolute value x plus 3 is greater than, let's go with 8 this time. It's a greater than, so that means it's outside that range. So it's either x plus 3 is less than negative 8, or x plus 3 is greater than 8. So here again we subtract 3, we get x is less than negative 11, or subtract 3, x is greater than 5. And there's our answer. So if it's greater than, the distance is outside, so we end up with or, with a less than and a greater than. If the absolute value is less than, it becomes between, an and type statement, where it's between these two values. All right, let's get a little more complicated now, because those were pretty simple. Let's look at this problem. Negative 3 times the absolute value of 2x minus 5 plus 14 is less than 2. How do we solve this? Well, just like with equations, the first thing we need to do is we need to isolate the absolute value. So we've got a multiplication and addition. We do the reverse of order of operations, so we're going to subtract that 14 because we're undoing. So we subtract 14 and we end up with negative 3, absolute value 2x minus 5 is less than negative 12. Now we divide by negative 3. Remember, when we divide by a negative, we're going to switch our inequality. So absolute value of 2x minus 5 is greater than 4. Now that our absolute value is by itself, we can compare this and decide, are we dealing with or and? We're talking about inside a range, so it's between two things, or outside. In this case, we're talking about outside because it's greater than 4. That distance is more than 4. So 2x minus 5 is less than negative 4, or 2x minus 5 is greater than 4. Add 5 to both sides of our inequality, and we get 2x is less than 1, so x is less than 1/2. And if we go over here, add 5, we get 2x is greater than 9, so x is greater than 9/2. And we put our or in the middle, less than this or greater than this. We've got our answer. It's going to be very similar if it's a less than. If we get this down to a less than, we deal with the between. 5 plus 3, absolute value of 4 minus x is less than 8. So when we do this, what do we do first? We've got 5 plus 3 times this. Order of operations would be multiplication first, then addition, so we do the reverse of that. We're going to subtract 5 first and get 3, absolute value 4 minus x is less than 3. Divide both sides by 3, we get the absolute value of 4 minus x is less than 1. Now we've got that less than with our absolute value, so that means it's going to be between two values. So we have negative 1 less than 4 minus x less than 1. Subtract 4 in all three sections, and we get negative 5 less than negative x less than negative 3. And finally, to get the x by itself, we divide everything by negative 1. Don't forget, dividing by negative 1 means we switch our inequalities. So we get 5 is greater than x, which is greater than 3. Which technically is our right answer, but we always write this in convention. We always want to write it going from smallest to largest. So we're going to switch this around and say 3 is less than x is less than 5. Simply because we're used to seeing the smallest number on the left and the largest on the right. 3 going up to 5 as opposed to 5 going down to 3. So 3 is less than x is less than 5. And there we have it. Now the weird thing comes here. What if we have this problem? 8 plus the absolute value of 3x minus 7 is greater than 5. Now, maybe if you're really thinking, you already see the problem. What are we going to do? We subtract 8 to make it more obvious, and now we've got the absolute value of 3x minus 7 is greater than negative 3. Remember, what does an absolute value mean? An absolute value means the distance. So we're saying that the distance is greater than negative 3. When is a distance ever negative? Or for that matter, when is an absolute value ever negative? Absolute value is always positive. So when we see an absolute value compared to a negative number, we always have to stop and just use some logic and think through, when is this absolute value bigger than negative 3? And the answer is always. A positive number is always greater than negative 3. And so this would be all real numbers. Woo! Big little loop there. This time we've got 4 minus the absolute value of 27x plus 1 is greater than 8. So we subtract 4 from both sides, we get negative the absolute value of 27x plus 1 is greater than 4. Got to get rid of this negative, so we divide by a negative and we get the absolute value of 27x plus 1 is less than negative 4. Now again, we have the same issue. We have an absolute value compared to a negative. This time it's less than. When is this positive number less than negative 4? Never. So we have no solution. So if we get an absolute value is greater than a negative, it's all real numbers. Absolute value is less than a negative, it's no solution. So when we're solving any of these, we first get our absolute value by itself, by subtracting 14, dividing by negative 3, and then we compare. Absolute value is greater than, so it's outside of a range. And so we deal with less than negative 4 or greater than positive 4. Absolute value is less than, means it's inside a range, so we say it's between. Negative 1 is less than 4 minus x, which is less than 1. And then we simplify and solve it. Remember to be careful. Where is it? Be careful with these. Do not add 5 plus 3. It's not 5 plus 3. It's 5 plus 3 times this whole thing. We can't add the 5 and the 3 to start with. So that is absolute value inequalities.